we will start with our webinar today. So today we have Gerald Kimmel and Sascha Smets in our call, and these two colleagues will present us today something about the Open Telecom Cloud Hybrid.
Yes, thank you. But actually Gerald wanted to start, so please, Gerald.
Yeah, welcome everybody. Hi. So thank you for your interest in the OTC hybrid topic. So we here from the hybrid spot, we take care of all the belongings of the platform, of the OTC hybrid platform. So today we will explain in general a little bit what is OTC hybrid anyway. So we want to show some typical use cases and explain some differences as well between the private and the public side, if there are any. So who is we? We, Stefan told it already, this is Sascha Smets, the product owner of OTC Hybrid, and me, the architect. So I'm handing over to Sascha.
Yes, thank you, Gerald. So let's jump into what do we actually have. So the OTC public, everybody knows well, I hope. So at least it's the Open Telecom Cloud community here. And but what is probably less known is a bit that we also have a private installation, and the private installation is basically, or it's based on exactly the same hardware and software as the public cloud. And this together then really forms this hybrid offering that we have. So the product is called hybrid, which sometimes may be misleading. I come to that later because we can also run it in a disconnected mode. But yeah, hybrid is the combination of two independent clouds, in our case then private and public, and this is our icon for this. So you will see that from time to time. So what is this OTC private or hybrid? So the private installation is first hardware and software, and this can be deployed in the customer's or T-Systems data center just as the customer wants to have it. So it can be that they have an own data center and they want to put it there. It may be that they even don't want an own data center, so we can host it for them. Everything is basically possible. So we basically only need some space where we can put the racks, power, cooling, and network connectivity. That's it. And depending on the use case of the customer, so whatever the customer wants to solve with it, or maybe also depending on the compliance requirements, this hybrid or the private installation can be connected to the public cloud or even not. So we can also run it in a disconnected mode. This is no issue for us. And it's also one of the differentiators to our competitors. So the only connection we really require is the administrative connection that you can see here in this lower left corner. So this is for our operations and maintenance team, and we need this to guarantee the SLAs that we offer, to monitor the platform and to maintain the software on top. But with the connection to the Open Telecom Cloud, which we always recommend, a lot of additional use cases are possible. And mainly Gerald will tell you about these use cases. So what is actually then the advantage of the whole hybrid operation? So we have defined several base packages as a kind of starting combination. We call it SML and extra large, so kind of t-shirt sizes. And these can be extended with additional capacity. So let's say virtualized compute hardware or bare metal servers or block or object storage, whatever is needed as capacity, and also with the necessary services. So there is a base set of services included already, which make it run basically, but additional services that may not be used by a customer are optional in the end, because all the services they require additional management capacity, and this requires additional hardware and software. And we don't want to put everything on it at once, so from the beginning, because it would result in many servers just heating the room without doing anything, so idling around, because not all services are used by our customers. But the good thing is you can basically select all those services if you want to. So, or just select a few, what you want. So we have customers that use RDS only. We have customers that want to use CCE, and we can then install this piece by piece. That's not a problem. So it's a kind of Lego brick selection So you tailor the whole environment to your own needs. And this is what it, for example, could look like. So this is an example of the hybrid size L. It contains a total of 28 compute servers for flavors. Yeah, let's say we call it the general purpose flavors. And these 1,456 physical cores mentioned here translate to almost 5,000 vCPUs with hyperthreading and overcommitment. But this is only the base configuration as mentioned. So, so similar to the public cloud, you can also select flavors without overcommitment, for example, or with special memory configurations. The total number, what you can also see here of nodes that is installed, it's not only the compute and storage capacity that you need, but also the OpenStack management, networking equipment like firewalls, core switches and stuff. And the whole number of nodes is over 100. On the bottom here, you can see then the services that are included by default. And as mentioned, you can have then additional services on top. Regarding connectivity, also Gerald will tell you a bit more in a minute. And yeah, now Gerald, please take over.
So the point is, what is so special about OTC hybrid? I mean, in general, you can combine a hybrid cloud out of completely different hyperscaler. I mean, it doesn't have to be OTC. It could be AWS or Azure or Google Cloud or whatever. However, some advantages come up if you're using OTC hybrid on both sides. So we will show some of these advantages from the technical perspective and see what are differences between OTC private and OTC public, if there are any. So from the view of the racks that just showed you, I will take you to a more logical view here. So if you see on the right side here, the Open Telecom Cloud Public, as a generally it consists of several hardware components which are residing in different data centers. On top of it, there is a virtualization layer, in our case an OpenStack virtualization, which is realizing a couple of services, and an API which is exposing it. So the special point about OTC private is that it's nearly a one-to-one copy of OTC public. Of course, not in that huge sizing, doesn't make sense. But it's based on the same hardware here, it's based on the same software stack and the same services that you have on the private side, you will find as well on the public side. And the APIs are the same. This is quite important when you want to use a hybrid installation, that you have the same API here. So you have the same offering, the same product, and if you ever realized hybrid projects, you know that you have a couple of challenges here. I will talk about two challenges. One is quite evident. It's the physical network connection that you have to realize. You have to have a connection between both. You could just use the internet connection between private and public. But you could as well use a dedicated line between the data centers here. So some of the customers don't want to have an internet connection, especially banks or insurance companies. They handle this very restrictive or doesn't want it at all. So this is as well possible. So just use an MPLS connection, something like this, between the data center, which would give you not only higher bandwidth and low latency, but as well more privacy here. And the second thing that you're facing is authentication. So in our case, OTC has the IAM, the Identity and Access Management Service that is responsible for the authentication. As you know, in OpenStack, all the services are frequently challenging the IAM service. Who made this request? Am I allowed to do this? Things like this. So it's important that the IAM database is consistent between all of the data centers. So you have different availability zones in different data centers, and this spans across different regions. So we are facing this now when we expand to Amsterdam. The IAM service needs to be consistent between all of the data centers. The important point is that any hybrid installation consisting of private and public has a completely different IAM database. So this limits somehow the use, and you always have two different entry points. It won't be possible, for instance, to have a web console having integrated hybrid resources consisting of private and public seamlessly. So it won't be possible to have a private installation integrated as an additional availability zone or as an additional region. You will always have two different web interfaces, and the same applies for command line. You always need two different command line commands. It won't be possible to address one command to different resources on both sides. Okay, so what are the differences? The difference is quite evident. So you're buying capacity on private. You're not using the pay-per-use model here. In the public environment, you just don't care. You claim your resources, you pay for them, and you release the resources. But on the private side, you have not the pay-per-use model, you have the pay-per-capacity model, which means that you as well need some sort of capacity management. So if your resources run out of capacity, you can add them, but then you own them for a certain time. So you make an additional contract for a couple of years, and you cannot get rid for them very easily. And this is where the hybrid use come into account, since you can borrow resources from the public side on the private side. So to give you a little understanding about the web console, this probably you know. This is the web console from OTC Public, all the services you have available, and in contrast, this would be a web console from a private installation. It's just the same. Evidently, it has fewer services. But when you drill down, you will encounter the same functionality where it makes sense. So evidently, if you have only one availability zone, for instance, certain functions are not possible here. But the behavior is the same, the functionality is the same, the services just function the same way. Let's step in and see concretely what we can do with a OTC hybrid here. The first and simplest use case is the resource expansion. So in the first use case we will show you here is having an ECS instance on the private side, on the left side. And this one will borrow resource from the public side. In this case, we want to use an OVS bucket, additional storage here, expanding the resources on the private side. So how does this work? There is some preparation necessary. So the preliminaries are create a bucket on the public side, have some credentials present, and on the private side, you have to install an additional package. For CentOS or Red Hat Enterprise Linux, this is the S3FSFuse package, which is contained in the EPEL. And together with this, you just store your credentials in a file and then mount the OBS bucket with the S3FS command. So this command takes the name of the bucket. It wants to know where do you want to mount it to. It wants to know where are your credentials stored, and it wants to know where you can authenticate to. Here it's the OBS service from public side. And together with this, you're done. And on your private side, you have an additional 256 terabyte from the public side, where you can do what you want to. Okay. The next use case is a little bit more complex. For the next use case, you want to use if you're doing migration or disaster recovery. So migration and disaster recovery is especially important when your business depends on the cloud resources. So migration itself is a planned task, so your blood pressure won't be that high if you're doing a migration. But disaster recovery is something where you have to prepare for. So migration is taking advantage of having both APIs identical on both sides. So if you have a couple of cloud resources in your cloud platform, there are already some services which can do automation or backup on these resources. So the RTS service, for instance, is setting up these resources or maintaining them. And CVR or SDRS is doing backups of these resources. On an external administrative VM, for instance, you make use of the API, which is doing a backup of the resources and storing this backup to local and copying this backup to the other side and then deploying the resource out of this backup. This is the way that you are doing migration here. For disaster recovery, on the other side, it is an advantage to have some cloud automation tools in place. For example, you could use Terraform or Ansible or the Cloud Topology Designer. I mean, you might ask why you should be prepared for disaster recovery if there's such a high availability guaranteed. But yeah, life is as it is. We experienced in the past a lot of customers having problems with either functioning something bad on their side. So some of the customers made mistakes, or even the hyperscaler make mistakes. So if your cloud business depends, if your business depends on the cloud resources, you should better be prepared for the disaster recovery. And in this case, you will set up an infrastructure as a code environment, which is able to address resources on both sides. This way, you can easily handle the disaster recovery. So in our case, what we will show is how to duplicate an ECS, a running ECS from private to public. How does it work in detail? We have a running ECS. This ECS is saved to the image service. So it's a snapshot which is taken here. This snapshot is stored to local, updated to public side, and then there will be a deployment of another ECS instance based off this image here. So what are the commands? First, let me give you a brief understanding about how to handle this. So imagine you have here an administrative VM. You could issue arbitrary commands here. In our case, we are using the OpenStack CLI. So if you want to see what kind of flavors we have, this command will just fail, since there is no authentication in place so far. So what you need to do is set up a configuration file. In fact, in this case, there are two configuration files. The secure YAML contains the authentication information, and the cloud YAML files contains information about how to address the platforms. So we have two sections here, a public section and a private section. And for each section, the necessary information how to access the platform is stored. So from a command, you have to expand by another parameter. And then you can address the platform here. And the same you can do for the private side. Another possibility would be to set an environment variable. And if you do this, you don't need this parameter anymore, and you're done. Okay, with this in mind, back to our migration use case. What are you going to do here? Let's see what kind of ECS instances exist. In this case, there is only one running instance. On the next command, we are doing a snapshot of this instance. The output is lengthy, so it's omitted here. Then we list the available snapshots. These are images on the private side. You get the ID here. And now you're retrieving this image to local. You save this file, demo private VM image in the QCode2 format, and you get a 5.8 gigabyte file here on local. So now you're switching to public side. You're uploading this image to the image service. And then you're just deploying a new ECS out of this image, and you're done. Now migration is finished here. Okay, so I already told something about disaster recovery. Disaster recovery is using the cloud automation tools that I mentioned before, and these are included in general in CI/CD chains. So in the next use case, we will show how are we going to address CI/CD chains to different cloud platforms here. We just show a portion of it. So imagine you have a Git repository where you upload your infrastructure as a code, and you have the executor. Then you just need a switch for the executor to execute your complex architectural code of the platform for the resources on both sides. How are we going to do this? We are using, in our example, an RTS template. Let me show you the contents of this template. So it's a heat template. The heat template is creating a couple of network resources and an ECS and doing some installation on this ECS. So in the beginning, you have to define a couple of parameters. These parameters allow you as well to configure different values if you need it on both sides. You can override these default parameters by command line switches. And then you define your resources based on the parameters. So you have a network here and a subnet and the network routers and interfaces, security groups with the ports. And you have your ECS instance, which has included a bash script doing the installation. In our case, there is a WordPress setup, some floating IP you need, and the port. So all these resources will be generated by this RTS template. And if you issue this now on the both sides, in our case, we are using it on private and on public side, you come to two different stacks. So the stack on the private side has the identical resources then, of course, with different IDs on the public side. So there are a couple of reasons why you should use this, not only disaster recovery. Another reason is development. couple of companies are using different cloud platforms for development. Reason could be cost, since public and private platforms might have different cost issues. So you're using for development the cheaper platform than you're using for production. Another could be privacy. Some companies just refuse to do their development on a public available cloud platform. So they are doing it on a private installation then. Okay, so the last use case I will talk about is the distributed workload. So this is as well something that uses resource sharing, but in this case it's an APC, an HPC use case that is creating resources on demand. So in this case, you have a private and a public side, which is connected with a VPN connection. And you have these job schedulers and HPC masters on both sides, which exist in any case. But the resources are created depending on the workload. So the job scheduler determines the workload and the number of resources you use, and the HPC master then are responsible for creating the resources or deleting the resources as it's needed. Yeah, these components in gray here, they cannot be realized by cloud intrinsic functions. So these you have to develop on your own. So either you could use on yourself some homemade scripts using the API, or you can use some professional tools. In the past, we used IBM LSF, for example, to set this up, and it was running well. Yeah, that's it already from my side. And with this, I will give back to Stefan for Q&A.
Thank you a lot for this good and informative presentation here. So in the chat, I had a look at it, but there we had no questions popping up. So then maybe to the audience, do you have any questions you want to ask rather Gerald or Sasha? Don't be shy. You can simply unmute yourself and then speak.
So one question that occasionally comes up is how are we comparing to other hyperscaler? Well, I can answer this. We don't mind to compare to other hyperscalers. So we did some comparison on our own. We are doing quite well. Of course, the number of services is not that high than on other famous hyperscalers, that's for sure. On the other side, when you compare the performance and the cost, we are doing quite good. And the fact that we are quasi duplicating the environment is something that I don't know from other hyperscalers. So this is something having a one-to-one copy on the private side that is quite unique on the market as well, especially if you take into account that customers can integrate their own hardware, for example. And this is as well used by our customers, and they are doing quite well with this. Yeah, maybe Sasha, you want to add something here?
I'm just thinking, so you mentioned most of the ideas that we have, especially for this event now. Yeah, there's a lot, let's say, going on, and maybe also one thing that is always under discussion, or people are asking, so what does it actually cost? So our cost model is actually based on first on an OPEX model. So it's only a rental model, so you don't have to invest anything. And on the other hand, we have a, let's say, full service with it. So we call it a turnkey solution. You get everything within that price. So there is no cost on top for example, for installation, for decommissioning. It's all included, including all the services that are also known from the public cloud. Like we have the training, we have 24/7 support. You can contact us via mail, phone. So we have hotlines and everything that the public cloud offers. It's also to be used by the private hybrid customers. So this is also, let's say, our idea of integrating these two worlds, the private and the public cloud, so that you get the same services everywhere. So I'm not sure if there may be also questions in other directions than the commercial parts. I'm happy to answer.
Maybe one question from customer view. What is the contract part? If you have a private cloud and we got a feedback from you that is a rent contract, but what is it if you like to use hybrid? Do you have two contracts, one for public and one for private, or how do you handle it?
Yeah, so the public, you don't have to get a fixed contract, right? So you can, let's say, take the resources in a pay-per-use model. So only if you use it, you pay for it. In the hybrid model, it's more like kind of reserving the infrastructure. So you have to bind yourself for quite some time. So normally, or let's say normally, the contract runtime is 3 years, but it's possible to extend that up to 5 years or to even go lower. So we also have a customer that only rented it for 1.5 years now. So there are all different kinds of models possible, but it's always a rental model. And then you have an additional contract for that, yes. On the other hand, you get also with the hybrid contract, you get also a tenant on the public cloud, so you're free to use it as well there.
Thanks. Good information.
Anything else you want to know about the hybrid cloud? I think nothing from the audience. Gerald, Sasha, anything on top you want to tell us?
Yeah, there are lots of things to say, but for this use case showcase, I think we shared the information that we should. But come to us if you have further questions, further needs. If you're thinking about a special use case that might not fit here into this model, just give us a call or an email, and we will see what we can do.
Yeah, absolutely.
Perfect.
Happy to support.
So your information how to contact you, we will put into this presentation. This will be uploaded later into the community portal. And with this, I would say, thank you a lot for participating. When you have any questions, please contact us. And then I wish you a nice rest of the Friday. Thank you all. Bye.
Great.
Thank you all. Bye-bye.
Bye-bye.
Thanks.
Thanks. Bye.